All right, you guys. So if you are Algebra 1, you already have this packet, so you'll be able to pull this out. It's at the end of Chapter 10. If you are an 8th grade math student, you'll just have to do this on a separate sheet of paper. So I highly suggest you take these notes down, pause it from time to time so you can copy down what you see, and then just listen to what I have to say. So this is the Pythagorean Theorem. It's going to be very beneficial for you to learn this or relearn this for either Algebra 1 or Geometry next year. So that's why we're going to focus this whole week on the Pythagorean Theorem. So the key idea is this. We have a right triangle. The two sides that create that right angle right there are going to be called your legs, right? So those create that right angle. Now the side that's across from the right angle, so I always like to draw an arrow, that's going to be your hypotenuse. And it's always the longest length. So the hypotenuse is always the longest length. And we can use the right triangle with their lengths to be able to find missing side lengths, to be able to determine whether something is a right triangle or not. You can do a lot with this. So what we're going to first do is find missing lengths. So here's the Pythagorean theorem. So in words, it's in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So again, that's that one across from the right angle. It's the longest length. Algebraically, you may have heard this before. It's a squared plus b squared equals c squared. So we're going to start simple, and then we'll get more complex, and then we'll try to go to different sites, whether it's still practicing the Algebra 1 rigor or even maybe going to geometry. So finding the length of a hypotenuse. So they give us this triangle. We're going to use this a squared plus b squared equals c squared. So I know that this, even they labeled it c, but even if they didn't label it c, I know it's my hypotenuse because it's across from the right angle. I know that these two lengths, 8 and 15, are my legs. So those are my a and b values. It doesn't matter, you can interchange, you could put a here and b here, it's just the ones that create that right angle. So then I would put these numbers in for a, b, and c to be able to figure out this missing hypotenuse. So instead of a, I'm going to replace a with 15. Put squared on it. Instead of b, I'm going to put in 8. And then c is missing, so I'm just going to keep it as is. So that's the start of it. You then have to evaluate this. So this would be 15 squared. You can do that by hand, 15 times 15. You can type it into your calculator, but that gets you 225. Plus 8 squared is 8 times 8, so that's 64. And then we don't know c squared still. Combine these together, you would get 289 equals c squared. And then this isn't my answer. 289 feet is not this length. That would not make sense. That's way too large. So I actually have to get rid of this squared. And if we remember back to solving, the opposite of squaring something is taking the square root. So we would square root both sides. The square root of 289 actually comes out to be 17. And you can do that in your calculator. You can do it online on an online calculator. Just take the square root of 289. And again, you'll see that 17 makes sense. So it would be 17 feet would be my solution. So that's finding the missing hypotenuse. And you see how this C, that's the one that's missing. Now, if we go on to the next page, here's some on your own. So I highly suggest you to pause it right here, try these on your own, or maybe do number 1 with me and then pause it and try number 2 on your own. So for number 1, I see that my 7 and my 24 are my legs. They create that right angle. So 7's A, 24 is B, and then C is my hypotenuse. It's across from the right angle. So it'd be 7 squared plus 24 squared equals c squared. And then you would have to then do get these values over here to eventually get c by itself. So 7 squared is going to be 49. Plus 24 squared is 24 times 24 is 576. and that's equal to c squared. Then you would combine these together. 576 plus 49, and when you do that, you get 625. And then that equals c squared. And then you would just have to take the square root of 625 to get rid of that squared. So this is my square that I need to get rid of. Square root it. Square root it. The square root cancels out the squared, so you get c equals, if you take the square root of 625, 25 would be your answer. So 25 times 25 gets you that. And again, it is the largest length, so that makes sense. So again, if you did not pause it yet, try to pause it now and try this next one on your own. And then check your answer. So here's my legs that create that right angle. So it'd be a value, b value. So it'd be 7 squared plus 10 squared equals c squared. 7 squared is 49. 10 squared is 100. And then that's equal to c squared. You would then combine these together. You get 149 equals c squared. Now this one, I mean, it all depends on the question, but let's say we end up taking the square root of this, and they just want us to round to the nearest tenth. So we'd actually have to take the square root of 149, and we would then round that to the nearest tenth. So let's take that. So I'm going to type in the square root of 149, hit equals, and I get about 12.2. And that would be my answer to that. So sometimes you can round. If they just wanted the exact answer, we would leave it as this, square root of 149. So that's finding the missing hypotenuse, the side that's across from the right angle. What if we wanted to find the missing leg? Let's say they give us the hypotenuse, right? So look at this one. They gave us the hypotenuse. They gave us the one that's across from the right angle. They didn't give us the b value. So that means this other length that creates the right angle is my a value. And then this one that's across, the 6.5 that's across from the right angle, is my c value. So I would then do the Pythagorean theorem. Instead of a, I would use 3.5 squared. And usually with decimals, I like to put those in parentheses. Plus b squared. And then equals my 6.5 squared. And then you can use your calculator to evaluate each one of these. And I would type in let's do 3.5 squared first. So 3.5, and I would square that, and you would end up getting 12.25 plus b squared, and then you would do 6.5 squared. So 6.5 squared, or really 6.5 times 6.5, that gets you 42.25. Now here's the difference. Up above, we were adding these numbers together, right there, right there. We added those numbers, but if we're solving for a missing leg, we're actually gonna have to move this, like solving equations, over that 12.25 to the other side. So I'd actually subtract the 12.25 from each side. This cancels out. You get b squared. And when you do 42.25 minus 12.25, you end up with 30. And then we just have to get rid of the squared, just like we did before. This is the same ending. It's always the same ending in the Pythagorean theorem. The opposite of squaring something is the square root. So we cancel those out. And again, you can either leave it as the square root of 30, but if you type that in, it is going to be an irrational number, and we'd have to then round it to the nearest tenth. So the square root of 30 gets you about 5.47, so I'll round that about to 5.5. Now, if you are in Algebra 1, we'll talk about maybe even simplifying this, right, by looking at the perfect squares that we've done before. Now here's a real life example. So this is really just putting it on the grid, so it's the same idea. So example 3 is, all right, we have these two paintball teams. A is located 70 feet north and 60 feet east of the base. So that's what they're talking about right here, 70 feet north, 60 feet east. That's how they got to this point for team A. Team B is 30 feet and 30 feet north, 30 feet east of the base. So north and east right there, 30 and 30. That's how they got to that spot. They want to know the distance here. And if you have a diagonal distance on the grid, you can't just count, right? You have to use some sort of either the distance formula, or in this case, we can use the Pythagorean theorem. So they then created a right triangle here. They went vertical and then horizontal, and they counted. They said, okay, this was 40 feet, this was 30 feet. Those are my two legs. I can then substitute those in from my A and my B values, and then I can find my C value, which would be my distance. So it'd be like this, 30 squared plus 40 squared equals C squared. So this 30 squared is 900, 40 squared is 1600, and then that equals C squared. And again, I'm getting those numbers by counting them on the grid by the vertical and the horizontal. Add these together, you get 2,500 equals C squared, and then if you square root that, you would end up getting 50. So those two teams, A and B, are 50 feet away from each other. So that's just on the grid. And again, don't ever try to count diagonally. You got to use some sort of math to get that distance. Either the distance formula, which we'll eventually learn, or the Pythagorean theorem, which many people like to do. All right, so here are some last examples for you. We have find the missing side lengths, right? So for both of these, if we look at both of these, they both gave us the hypotenuse. And again, pause here if you feel comfortable. Try to do this on your own. Otherwise, follow along. So they give me my C, they give me my B, they just don't give me my A. So I would write this out as A squared plus 1.2 squared equals my C value, which is 1.3 squared. So now I type in 1.3 squared to get what that equals, and that ends up getting you 1.69 equals 1.2. I forgot to put the squared there. 1.2 squared is actually going to be 1.44. It's kind of like 12 times 12. And then you don't have the A squared yet. So again, it's different. We don't add these together. We actually have to move this over like we're solving equations. And when you do that, you get A squared equals, and 1.69 minus 1.44, you would either do that by hand, or you can, again, type that in your calculator, and you would get 0.25. You would then just have to square root that at the end, and you get the square root of 0.25 to be 0.5. And that'd be your answer. We can do this one now. Again, they don't give us, or they do give us our A value. They don't give us our B value. These are the two legs that create the right angle. And then this is my C value. So it'd be 10 squared plus, we don't know our B value, B squared equals 16 squared. So you would then do this, and you would do 10 squared, which is 100 plus B squared, and then 16 squared, 16 times 16 is 256. You would then subtract 100 over. You'd get B squared equals 156. And then again, this is a non-perfect square, so I'd have to take the square root of it, and I would round it. Unless you're in Algebra 1, we'll start talking about simplifying these square roots, but this would be rounded, if I square root both sides, to about 12. I got 12.48, so I'll round it to 12.5. All right. So we'll stop there. I think that's enough practice for the Pythagorean theorem. I'll put you on iExcel. I have a video for that too, where I can kind of talk you through it again to help you through it. And just practicing this a lot will help you in both algebra and geometry next year. So we're going to spend a whole entire week on this. We will get to more challenging problems. We just need to review the basics or learn the basics.